Our next lesson is called Simplifying Square Roots. So we will start with an opening exercise where you're going to answer questions 1 through 6 about square roots. So at this point, if you would pause the video, please, try 1 through 6 on your own, and then resume the video to go over the answers with me when you are done. Okay, 1A, what does the square root of 16 equal? That should be 4. Part B, what does 4 times 4 equal? That should be 16. And C, does the square root of 16 equal the square root of 4 times 4? The answer is yes. In number 2, what does the square root of 36 equal? It should be 6. B, what does 6 times 6 equal? That would be 36. And C, does the square root of 36 actually equal the square root of 6 times 6? The answer is yes. In number 3, what does the square root of 121 equal? That would be 11. What does 11 times 11 equal? That would be 121. And does the square root of 121 equal the square root of 11 times 11? Yes. Number 4, what does the square root of 81 equal? That should be 9. What does 9 times 9 equal? 81. Does the square root of 81 equal the square root of 9 times 9? The answer, yes. So looking at number 5, what is another way to write the square root of 20, and what is another way to write the square root of 28? Okay, so some examples of what I was trying to have you do here was to do something similar to part C, where you break down the number underneath the radical into their factors. So let's do some examples of what you might have written. You could break down the square root of 20 down to the square root of 2 times the square root of 10, or the square root of 4 times the square root of 5, or the square root of 1 times the square root of 20. For the square root of 28 and number 6, what is another way to write that? Again, several examples. We could have the square root of 1 times 28. We could have the square root of 2 times 14. We could have the square root of 4 times 7. So these are all ways of taking the number underneath and breaking them down into factors. However, in order to simplify square roots the way that we need to, there's one of these in particular that we're going to want to use. So I will show you by circling, and then we will discuss how to simplify radicals on the next page. We would want this choice and this choice. Okay, so now let's go into some examples of how to actually simplify square roots as much as possible so you understand the process. For your reference, over on the side, you're going to notice right here, we have given you a table of your perfect squares and also your square roots just to help assist you with this whole process. And we will start with example 1. We want to simplify the square root as much as possible. So whenever you're simplifying a square root, why don't we write this over here on the side? You want to break this down so that you have 2 factors. This first number should be the largest perfect square factor. And this number will just have to be whatever other factor you need to make those 2 numbers multiply to the original number underneath that square root symbol. So if we look at example 1, I want the largest perfect square that divides evenly into 50. So we're not looking and saying, oh, it's 49. 49 is not the largest factor perfect square. Okay, so be careful of that. We want the largest perfect square factor. So in that case, it would be 25. So we would break the square root of 50 into 25 times 2. So then we can split this up, square root of 25 times the square root of 2. And we ask ourselves, can we take the square root of 25 nicely? Yes, we can. 25 is a perfect square. That's why we pick it the way we do. So this becomes 5. Can we nicely take the square root of 2? No, we cannot. So that stays underneath the radical symbol, and our answer is 5 square root 2. We should not be able to break down the number under the radical anymore, or we have not found the largest simplification. Okay, example 2. We're going to simplify the square root as much as possible, but you're going to notice this time we have a number out here in front, so I want to show you what that means for us. So we're going to write the 2 because it's part of the problem. And then we're going to take the square root of 28 and break it down into factors. So the first factor we want to pick is the largest perfect square factor. Looking at the list, that would be 4. We would have to multiply 4 by 7 to get 28. So now I can separate these into the square root of 4 and the square root of 7. So we've got 2. Can we take the square root of 4? We can, nicely. It's a perfect square. It's 2. That becomes a 2, and we're going to put it in parentheses so it doesn't look like 22. Remember, that's still multiplication there. And then can I nicely take the square root of 7? No, I cannot, so that stays underneath. 2 times 2 is 4. So my answer should be 4 square root 7. Again, I know I've simplified it the entire way because 7 cannot be broken down anymore. Example 3. Simplify the square root as much as possible. So we have this 1/4 here that we must keep. And we are going to break down 128 into the largest perfect square factor first times whatever other factor we need. So looking at that list, the largest perfect square factor would be 64 that divides evenly into 128. And we would have to multiply that by 2. So we get 1/4 square root of 64, square root of 2, which would be 1/4. Can I take the square root of 64? I can. It's a perfect square. It's 8. Can I take the square root of 2 nicely? No, it is not a perfect square, so it stays underneath. And then all I have to do is 1/4 of 8, which is 2. So I get 2 square root 2. Now, before we summarize down here, we want to talk about what happens if you do not pick the largest one, okay? If that happens, you may just have to repeat the process, okay? So, for example, if we didn't notice that 64 was the largest factor of 128, and let's say we just thought it was maybe 4, okay? I will show you here on the bottom, just so you can have an idea of what we're talking about. So let's say that I took the square root of 128, and I made it the square root of 4 times 32. Then this would be square root of 4, square root of 32. I'd get 2 square root 32, and you think, oh, I simplified it. However, you have to look at the number underneath and make sure it can't be broken down any further. We have numbers that can go into 32. So we would have to break that down again. So if I take 32, 16 goes into 32. So I'd have to come over here and repeat the process. So it'd be 2, then I would break down the square root of 32 into 16 and 2. So this would become 2 square root 16, square root of 2. But we know the square root of 16 is really 8. So we'd get 16 square root of 2. Now, I didn't include the 1/4 from before, but obviously if we did the 1/4, it would change the value there, okay, in front of that. So I just want to make sure you understand that you can get to the correct answer eventually, but you would have to repeat the process. So we really want to try and find the largest perfect square factor right from the start so that we do not run into that issue. Okay, so as a summary, remember, square roots of non-perfect squares can be simplified using the factors of the number. Any perfect square factors of a number can be simplified. And you have another example down at the bottom using the square root of 72. And that concludes your lesson on simplifying square roots.